please join me on page 9 of your packet. You should be watching this after you've learned about position versus time graphs. Let's now learn about another representation called a motion map. There you go, the M is hiding. Motion is a mostly qualitative way to look at moving. It really helps us see the direction of travel and compare the rate of travel. It is less detail-oriented than the position versus time graph. So I have you imagine that I'm taking a series of pictures of an object moving along, and then we clock its position in every one of these pictures. And what is key is that each one of these pictures is taken at the same interval of time apart from each other. So, let's say this is a half a second between these two photographs or snapshots of this car location. This is what the motion map would look like. It's an axis labeled with position and a dot representing the location of the car and an arrow representing the direction of travel. Compare these two situations. In the second situation, the car's traveling at a greater velocity. How do we know this is a greater velocity without being told? Well, we can see that for the same time interval, this car starting at the same location, actually this car travels a greater distance ahead in the same time interval. That means the velocity is greater. This is how these two motion maps would compare. Motion map number 2 shows a greater displacement of the car between each time interval as compared to up here. So it can be a great qualitative way to understand motion. Another way that the motion map can show motion is to show direction. Now, of course, we can show more complicated motions. Let's take a look at this object. We're going to start here. Right at a constant velocity. We know that because these snapshots are taken at the same time intervals from each other. And how far the object travels, its displacement, remains the same in each of these 4 snapshots. Then it hits this location, and for 3 ticks of the clock is at the same location. So imagine these pictures being 1 second apart from each other. Boom, boom, boom. We're moving forward. And then all of a sudden we come to a stop and we hang out there for a little while. And then we reverse direction. And now we're traveling at a different speed. This velocity here, traveling in the other direction, traveling to the left, is smaller than this velocity here. How do I know that? Well, this is 1, 2, 3, 4 locations. We haven't traveled as far as we did here in 1, 2, 3, 4 locations, right? Smaller displacement for the same chunk of time, smaller velocity. This is how a motion map works. I want to stress that in this class, we'll be making semi-qualitative or exclusively qualitative maps. We're not trying to put numbers on them. We're going to let that happen on a position time graph. Now, one important thing about reading a position time graph is being able to compare 2 objects' motion. Look at A and B. They're both starting at the same moment in time. Who gets the head start here, A or B? Correct. It's cyclist A. They're starting ahead of cyclist B. At what point does cyclist B overtake cyclist A? When do they pass them? We have to remember that these snapshots were taken at different intervals of time. So here's 0 on the clock for this guy, here's 0 on the clock for this one. Here's 1 on the clock for this one, here's 1 on the clock for this one. Let's continue doing that until cyclist B overtakes cyclist A. Right? So don't look at the point where there's 2 arrows that line up with each. The point where there's 2 arrows that line up with each other that have the same clock tick measurement. This is the moment when cyclist B is passing cyclist A. We could also show that on a position time graph like so. Cyclist B starts behind cyclist A. Cyclist B gains a greater position than A at this moment in time. And then finally, we can show this as an equation too. This now means that you've got 3 representations of the exact same motion. Depending on a situation, you might find one representation more useful than another. But in the interest of being able to share your understanding with others, we're going to be using multiple representations so that a graph that speaks to you can compare to a motion map that might speak to a classmate, might compare to an equation that could speak to another. That's how motion maps work. After you have the basics of motion maps, let's pause there and pick up in a moment.